Your Zoom is there. You go.
Yeah.
And we are live. Hello, everybody. Welcome to this morning's Hour of Code Coding Unplugged grades K through 3. I'm James O'Hagan. I'm going to be the back end support today, but I want to turn everything over to Mary Walker Hope, your teacher for this morning. So thank you, everybody.
Good morning. Yes, good morning. So, as you just heard from James, I'm here with you as well, but I'm from Brighton, Ontario. So I don't know where you're joining us from today, and we're going to be finding that out from you. And I'm going to send things back over to James for a minute after as well. But James, do you want to introduce yourself as well and let everybody know where you're from?
Sure, yes. My name is James O'Hagan. I am a teacher in Racine, Wisconsin. We sit right between Milwaukee and Chicago along the Lake Michigan, and we are on Potawatomi land, based
Nice.
on the treaty from 1833.
Oh, wow. And so where I'm from actually is on the treaty, the 1923 Williams Treaty. And so for everyone, our land acknowledgement today, it's very likely that you're participating and learning from or near a territorial land of one of the many Indigenous groups across Canada. And I know James is from the States as well, but a lot of our people are coming in from Canada usually. So I acknowledge as well that I'm presenting from the territory of the local people of the 1923 Williams Treaty. That's the Anishinaabe, the Mississauga, the Haudenosaunee, and the Wendat people, on whose beautiful land I'm able to teach and learn with you. And yeah, I couldn't ask to be in a better place. I don't know if you've got a lot of lakes and rivers and trees and everything around you, James, but we sure do here.
Oh, Lake Michigan. I mean, I go right out the door and it's 3 miles to my east. So I'm right
Nice.
there.
Very, very cool. All right. And James, do you want to thank Google for us as well? Do that part?
Oh, absolutely. Well, we need to thank Sandy Curry for making sure that we have this opportunity to bring this to you today. So thank you to Google Canada. Thank you to Sandy for making sure that we can be here with Logix Academy, myself and Mary, to bring this event to you today.
Absolutely. And so, James, I'll let you do this as well, actually, because I know you like doing this is your backdoor stuff. So away you go. Go ahead.
Well, we would love to see, you can see us and hear us, but we obviously can't see you today. We cannot hear you today, unfortunately, because of the way that we are streaming out to the world through um, YouTube. But we do have, if you go to this bit.ly, whether your teacher or yourself can go to this bit.ly, you can tell us exactly where you're from. So bit.ly/. Logix Form 2, and that will let you tell us where you are in the world.
Yeah. And so for me, I mean, we do want to know where everybody is from and everything today too. We do ask that you just put down your first name, or if you want to put down your class name, if you're the teacher that's with that class, then please feel free to tell us where you're from and what grade you're in as well. That would be great. And if you have a chance as well, once you're getting this set up, and we'll do a little talking while we're getting people coming in. But while you're getting set up, if you let us know as well, what do you think unplugged coding even is? That's what you joined today, was to find out about unplugged coding. And we'd love to find out what you think that might be as well, okay? And again, as James was saying, you can answer at bit.ly. So it's going to be bit.ly/, then Logix Forum 2, number 2. And I see that we already have some people coming in there. Can you see that, James, as well on the forum?
I cannot see it. I do not have access to the forum.
Oh no! Oh dear! Well, we'll have to get you in on the forum, because it's a great place to be able to see the kids. If you go into the Slack back on our thing, you'll be able to find the forum in there and get in with us as well. So sister Zubada. I don't know. Maybe you'll have to phonetically give that to me if I'm doing that totally wrong, and I'm very sorry if I am. But we're at GLA Ajax. So Ajax is joining us this morning, and I know we have some other schools there too. So if you're just joining us, hello, and come in and set up just one oh, I was going to say URL, but one tab, set a tab up on some computer somewhere so that you can talk back and forth with us. Oh, and thank you. She said Zubada. Zubada, I got it. Thank you so, so much. And it's lovely to have you here with us today. I hope that you get to do some really fun things with us as well. All right. So we, and Ishrael says, unplugged coding is without tech, maybe. That's a neat idea. I like that. I like that. Okay. Let's see if we get some other answers coming in through as well. Okay. But we'll keep going. And as people come in, we'll give a shout out and let you know that you're there. Okay. And if I get a chance, I'll send you that quick link for you too there, James, so that you have the form. All right. Today's plan though, today, what we're going to do, we're going to find out what is unplugged coding. And that's why my question for you is, what do you think unplugged coding is? Before we even get into this. And yeah, definitely there are clues in the words as to what it's going to be. We're going to take a look and figure out what an algorithm is. And I know if you're in kindergarten and watching this, you're likely thinking, I have no idea what that means. But guess what? At the end of today, you are going to know what it means. And you can go home and tell mom and dad or your family, this is what do you think an algorithm is? And they'll just be blown away with your knowledge. So we get to be human robots today as well. We're going to be doing some movement and things and being human robots. We're going to learn a thing called binary coding as well, just a little tiny bit of it. And just to get you introduced to it, to understand what it is. And then we're going to code a letter. So we'll see how that all goes as we're into all of this, okay? So what is coding first? So coding, as we know, it's a set of instructions, okay? So in a computer, or it could be in a computer, but coding is a set of instructions to get someone or something to do something for you by communicating very clearly. So steps have to be given very clearly for someone or something to follow our instructions. And that's what coding is all about. So if we had, for example, looking at coding online, there's a whole bunch of people that always are doing this. And so coding, it was Scratch. It's one of the popular things that as you get a little bit older, you might be going in and doing. If you do Hour of Code during December in this week, in this computer science week, then you might already have been looking at and thinking about CS First or Scratch. And those are ways that we make computers do coding. But we were saying, and I see that we've got a few more answers there as well, that unplugged coding is don't use any computer whatsoever. And well done. That's exactly what it is. So unplugged coding is just a set of instructions that gets someone to do something by really communicating clearly. No computer needed whatsoever. And that's what we're going to do today. All right. So James, come join me. I need you here.
I'm coming back.
Oh,
I was
that's
just
good. That's
popping in.
perfect. That's great. So, James, we live in two different places in our little town here. How am I going to go visit James, right? If I don't have clear directions on getting there, I'm never going to make it to his house. So, James, what if I'm the little red house down in the middle of our screen, just over here, and you
Yes.
are the big yellow building over here? What would be one set of instructions that you could give to me to come over and eat some Christmas cookies?
Gosh, there's so many. What I love is that there's so many different options that you could take. I mean, do we want to take the most direct route because you're so hungry and you're ready for cookies? Or do I want to send you on the very beautiful, longer, by the river kind of route where, you can see some of the lovely things around my house here?
That's
Um,
true. I'll tell you why. I'm going to ask you to give me the shortest route because it's really cold out today.
okay. Well, then I can go one of two ways, really. I can either go straight left to the yellow and blue house, and then the diagonal, yeah, northwest, excuse me, through the yellow building, or I could go from my red house to the red and green house, which is
Ah,
also 3 steps, and then 3 steps towards your house.
and you know what, James? I love the fact that you said to me it's 3 steps to the yellow and blue house. It's 3 steps to the yellow house. Those are really clear directions to me. And the only thing that I would love to hear a little bit of as well, if I was waiting for my directions, is which direction am I going in? And you said go northwest, because I know James noticed that there is a lovely compass up here in the corner. So we could use that compass, but in grade 1, maybe all we want to say is go left or go right, and we could do that. So if you want to send me, I'm actually going to move our arrows, and I will actually put arrows where you want me to go. So let's just maybe do the straight to the yellow, blue, and up.
So yes, take that arrow and place it, that right there is perfect.
Okay.
And two more in the boxes next to it.
And which direction am I going, James?
West.
Okay. All right. So I'm going west or left, which is fine for our little ones. And so I'm putting 2 of those in there. Beautiful. So that was very clear. I know exactly where I'm at, but I'm not at your house yet, am I?
Nope, nope. So what we will do then is we're going to take another arrow and go northwest from that house, following the path northwest.
So I have to turn it a little bit then, because I have a little turn. Oh, I have a turn thing. Of course, I'm trying to do it on a very small screen there. That's not good, but that's okay. Get the idea. I've gone there, and you know what I'm going to do is just copy that one. And how many more northwest steps do I have to do?
2, please.
Okay, so I'll take that one and put it there, and 1 more. And there we are. I've arrived at James's house, and we get to have some cookies. I hope you have hot chocolate ready too. I love hot chocolate.
I can make that, no problems.
Beautiful, beautiful. Okay, so clear directions. That's what coding is all about, is that whether it's a computer telling us that we type in things and get the computer to do it for us, or whether we do it with our voices, it's still, or with symbols, it's still going to have to be nice and clear. Okay, so that's the directions that are there. All right, let's see if I can get ourselves moving on here. There we go. So here's that big question. And this is where we need you answering as well. I know all those classes out there. What is an algorithm? This is where we're going to find out what is that big word meaning, okay? So that's the big word question for today. What is an algorithm? So get out that tab, get your teachers to write for you, send out all your ideas to your teacher, and answer us on that bit.ly. So the bit.ly, if you're just joining us, open up a new tab, and there's a form that you'll see. Please don't put any last names in it, just your first name, and tell us what is an algorithm. And James, I'll let you think about that one too while we're waiting. Yeah.
I mean, it's such a odd word, isn't it?
It is.
Algorithm.
And it's not like I try to look at words and kind of think what do the parts make up, right? And the only thing that I really get in there is the rhythm part.
I was going to say that myself.
Yeah. And if that had something there. Oh, okay. So we have James saying that he thinks an algorithm is a plan. A plan. Okay. That's an interesting thought, isn't it? A plan. All right. Well, I'm going to go ahead. And if you have more ideas, please put them into the form. That's great. But an algorithm. So it's just a set of specific steps. So what James was giving to me already were those steps of how I was going to get to his house. It's a set of specific steps that you follow to solve a problem. So in programming, when you're inside the computer, algorithms can be used over and over and over to get the same result. But we can also do something else as well with the algorithm to change it and make something new too. And we're going to do that very, very soon. Okay. All right. So here I am up in my top corner, and oh my gosh, am I like talking about food only today? I don't know. It's sort of a theme happening here. So I love donuts as well. Donuts are grand as well. So I think in our form, oh, that's great. So Israel said it tells something what to do as well. So thank you for coming up with that one as well. So in the form, if you would like to, I mean, James is going to direct me, and that's fine and dandy. He's going to give me directions of what to do. And this one's a nice simple one. But if you're looking at this as well in your classroom, then please put into the form, what do you think my directions or James's directions are going to have to be to get me from here in this top right corner in this block? How do I get down to the donut? How do I go and get my food? Okay. You can see that we have turn arrows. So I can turn up, I can turn left, I can turn right, I can go right, I can go left, I can go down, or I can go up. Okay, those are our directions. Put into the form, if you can, what you think is going to end up happening. And we'll see whether what you put in is the same as what James tells me to do. So James, I need to get to the donut. What's the fastest way that I can go? Let's do that one first.
Oh, well, the fastest way, because I was thinking as we're eating donuts and talking about foods, they were probably going to need some exercise. So I was going to have you get some steps in before getting to the donut. But
Fair.
in
No,
this
fair, fair.
case,
We can do that. That's absolutely fine too. Yep.
but if I was going to get you to the donut as quickly as possible, because there is nothing like a fresh donut, I would just have you move down
Okay,
two
so I
squares.
take a down, one down arrow, and
Hmm.
then two steps down, and boom, I'm on my donut, aren't I? I'm right there. Yeah. And
Yeah.
that's the simplest thing. And there you go. Sister Zubida, they said down, down. Perfect. That's exactly what we need to do. Now, as James was just saying, we could go get some exercise first and meander around and do some of that as well. And so, James, why don't you do that just very quickly? Let's see what we could do, and maybe we can get someone from our friends that are watching us. Maybe they can put in a path for us to go as well.
Well, I mean, I would be curious to see if anybody could figure out what's the most. Could we use all the squares without having you have to double back? So I would try to get you to go. Let's see, left, left.
Okay, so left, left. And I know when you say left, left, that I'm not going up or down yet. So I knew to put those arrows into those two blocks. Uh-huh.
And then I would have you make a left turn and go down.
Okay, so I'm going to have to take this arrow and just turn it all the way around to go downwards, right? So
Yeah.
there we are. Okay, so now I'm going down. Just make
Yep.
it so. Yep, I got it.
And then so you're down in that, you're in that, yes, that square right there on the left. I would
Okay.
have you go down, down. So you're ending up at the bottom left square.
Oh my gosh, down and down again. I love this. Uh-huh.
And then I would have you turn to the, actually, because you're facing down right now, I want you to go left. But I would,
I have to turn first, right? To
yeah,
face that way. Yep,
yeah, you would have,
absolutely. So I'm going to turn myself around so that I'm
yeah,
going to turn that way. Okay.
right. So now you're going to go right. Now I'm going to tease you a little bit because I'm going to get you close to the donut, but not quite to the donut yet.
Oh my gosh.
I
Okay.
want you to see it. So, yeah. And then I'm going to have you turn and go up one square.
Oh, okay. Yep. I got to get a turn one back in again. Oh, I love that. Oh, that was my last turn, but that's okay. I can make more.
And
Okay.
then I will have you go right, right, and then down.
Okay. Do I want to, if I've turned, am I going,
Oh,
do
you
I
got to
not
go up first.
I have to go up first, don't I? Isn't that
Yes.
cool? When you think
Yeah.
about that, yep, that would have been a bug in our code. That would have made a mistake if we had tried to do that. Yeah, I had somebody walk that through. Okay, so I've made it to there. And now you're right. I have to turn. Oh my word, I have to turn yet again. This is complicated. I hope our little kindergartens are
I'm
able to
sorry,
do
kindergartners, but
it.
I
This
wanted
is
to
for
see if I
our
could
grade
use
two.
every square.
I know, I love the idea. Okay, and then
Go right,
okay, perfect. So now I'm on this square.
and then we're going to have you turn right and go down.
Okay, so I'm going to copy that one and put it so that we turn. Imagine doing this. You could be doing this with your class even. Have them stand and do these. We're going to be human robots soon, so you'll see. Okay, and then I'm not quite at my donut though, am I? I've turned, but am I on top of my donut yet?
Nope, you have to go down one.
Okay, down one. And voila, we made it.
You got your
Amazing.
steps in.
I did. I did. And that's
But you
neat
know
to
what but you know what I love, Miss Hope, is that we had two different ways to get to the same place. One may be more faster than the other, but it still got us to the same location.
That's right. And that's what's wonderful about coding is that will always happen, that we have all kinds of different ways of doing it. So that's really neat. Okay. All right. So it's a little bit of human coding time. We can do this now with ourselves, which is kind of fun. So we already did a really complicated one and ended up making that one nice and complicated. And I think right away everyone's going to be able to see that we could go very quickly and get down to the koala. And as James said, we could even um, um, try to do as many of the blocks as we wanted to, or we know that different paths will still get us there no matter what, and we still get to the same spot. We get to the right place. So if I was to quickly do this, and I know likely our classes in that are watching right now, if you want to throw in a code for us so that we have directions which way to go. So and make sure that you put in the turns too. This one would be really, really simple to do. And if I want you at home to be trying, or back at school, to be trying to take a look at this and just figure it out before James and I do anything. So now that I've been talking, hopefully you're already looking at it in your school and thinking, okay, how would I want to go and take that picture of that koala. So how am I going to get to it? Okay. There we go. Oh, okay. So we have James's class is again saying, so this time down, down, turn left. So down, let's see, down, down. So James and your class, lovely. I love the fact that you said that, but you didn't tell me which way to turn. So I could have turned to the right, or I could have turned to the left. So that's part of that code thing to think about it as well, right? So we have to have those specific words in there, those specific algorithms. So down, down, and turn to the left, and then left, and we're on the koala. Okay. And I'm not going to take a lot of time with that because we did such a great job with the other one, James, of showing how that all works together. But I could definitely I'll put James's one in here so that he can see that it definitely worked. So down, down. And then, as I said, I had 4 different turns I could have done, but I needed to know that I needed to turn to the left. So turn left and then left. And boom, I get my beautiful snapshot, National Geographic shot of this beautiful koala, and we're all there. Yeah. Did you have a different way too, James?
Um, I might have had you go left first, then turn so that you're facing down, and then you go down, down.
Right, right. So turning that direction. Yeah, exactly. So it could have been anything, and that's great. Okay. All right. Well, let's get on and get doing. So I'm asking as well, did anyone at home, or at home, I keep saying at home, but I'm at home. You're not at home. You're at school. That's okay. But it's anybody have a different way to get to the koala? But we were kind of talking about that too. So if you do, put it in the form and we'll shout it out when we get to that as well. But right now, I would like you, because it's, we got to move a little bit too, don't we? While we're doing all of these things, we don't want to just be sitting looking at James and I. So what we were going to do as well is a thing called mirror, mirror, which we do all the time, or can do all the time in drama. And you have one person moves a certain way and the other person moves that exact same way. So maybe in your classes right now, you can just see your elbow buddy, somebody that's sitting just beside you. And if there isn't enough people for just groups of 2, make a group of 3. You can have 2 people mirror you, and that's just fine too. It makes no odds. But maybe right now, just you can kind of settle and figure that out, and we'll give you just a moment to do that. Oh, and James, what you're going to do is you're going to mirror what I'm doing. Okay.
Okay.
So you're my mirror. Okay. So you'll just be my mirror. And I think we can do it. I'll just make sure that my hands and that stay at close to where we're at. All right. So I already see James has his hands the way that I do. So everyone at home, you can do your own mirror. You don't have to follow what we're doing, but we're going to actually do a mirror, and we're going to let you do that as well. Okay. So with your partners, just don't say a word, but start
Oh, wait. Here,
moving.
let me just make one
Yeah. Oh,
adjustment.
that's perfect. Yeah, that's a great idea. Okay, so here we are. All right, ready? And I'm going to move quite slowly.
Oh, wait,
Oh,
because I'm on, wait, I can't, the camera has me flipped.
That's amazing. So you're going to have to do it opposite. Okay, well, this is good. This is like, we'll get our brains working today. Okay, and you know what? That's fine, because in a mirror, you would be flipped. Aha. So your partner is going to do that. Well done. Okay. I got to come back in. There we go. Oops. I'm doing the same thing. Rudolph. It almost worked. There we go. Rudolph the Red-Nosed Reindeer. We got him. I hope that you're able to do that in your class as well. All right. Okay. So James was able to see me. But what happens? Oh, James, leave us up there again for a
Oh,
minute, okay? Because now in the classroom, what we want you to do is with your partner, this time we want you to tell them what you're doing. They're going to have their eyes closed, and by the time that you finish, so you're just going to give them 3 directions, okay? So you might say, put your left hand on your head. Okay, so James, do that for me. And he's got his eyes closed. So I said, put your left hand on your head. Then I might say, put your right hand on your right ear. Nice. And what can I have you do that isn't a hand? I can say, because we can only show our heads. You can do more things in your classroom. Okay, James, open your left eye really wide. Oh, and he's got his glasses on, so we can't quite see, but that's okay. All right. So James, what our partners would then do is, at the same time that I'm telling you to do that, I would have been, and I'll do it this way so we see it the same way as well. That way and there, right? So when they open their eyes, if you look at your partner, you should have your hands or whatever it is that you did in the exact same place as your partner. Okay, so you can put your hands down if you want, James, for a second. So in your classroom right now, what you're doing is with your partner, one partner is giving 3 directions. And you say them very clearly. And remember, if you want a right hand or a left hand, make sure you use that. So we're going to give you a minute to try that. And James, if you want to, in our private chat, give me 3 directions, I'll do that. And then we'll come back to our students.
oh, I didn't tell you which hand.
Nope, but that's okay. All right. I'm going to just stop for a second. I'll come back to that. All right. So hopefully your first partner has gone. And did your partner actually do what it was that you wanted them to do? Because James and I noticed when James wrote to me so that we weren't disturbing you while you were doing that. We're going to let your second person, now let your partner do the same thing back for you. But what we noticed was James just said, put your hand on your left earlobe. So I purposely put my right hand over there. And he's like, oops, nope, it wasn't the same. So second partner, go ahead. You try it as well. I'll do one for you. All right, we've had a chance to do it for our R's. I hope that you've had a chance there too. So in your classrooms, I wish we could see what you're doing, but if you see James now, I asked him to put his right baby finger in his ear, and I forgot to say in his left ear or right ear, whichever one. And then I told him, put your left ear down towards your left shoulder and put your right hand on your mouth. And so he's doing it. Thank you, James. So that's great. So again, it's those clear instructions. You just made an algorithm. Okay. You just told your partner how to actually make an algorithm as well. So well done, everybody. You've done that. I hope that that went well in your classes. Okay. Back we go there, James. We'll get the slide deck back up as well. Excellent. Okay. And let's go on to our next slide as well. And if you're just joining us, because I'm seeing that we just had some people joining us as well, maybe I think we might be able to give our bit.ly back up again too. Let me just see. Oh, it'll come up in just a moment and you'll be able to join us and talk to us as well, okay? So we're not going to do this right now, but this is just something for you to think about that is something that you definitely could do. So if you take a fairy tale of any kind or story of any kind that you've made, and you want the characters to be able to get from one spot to the other, then I know that your teachers can create the different arrows, or you can make arrows on pieces of paper, and you can actually make your character go from one place to another. And obviously in this one, we have Little Red Riding Hood, and we didn't want to meet the wolf. So we had to make sure that the path went around the wolf. So it was either, they turn left or turn right, or go left, go right, go down. But the path is created, and you can even do this with Lego, with anything, and show it and have one person set up what they think is what their code is going to be, and then have another person follow your code. So follow what you've written down, or how you've placed all the different arrows and things, and see if they make it to the spot that you want them to get to. So that's something for you to take a look at and think about for later, not right now, okay? All right. Uh-oh. There actually is two words, but decomposition is just another word that happens in coding. And there's our bit.ly, so that if we have a class joining us, please join us on that bit.ly. So it's bit.ly/logicsform2, and you can be talking to us as well on our forum as we go along. So what's decomposition? Don't worry. I'm not going to ask everybody to try and figure it out, but in coding, decomposition is when you break down a problem into smaller pieces and to make it easier to understand. So one thing that happens when you break down into all those smaller pieces is that you can actually make something brand new by just taking those same pieces and use them in a different way. So I'm going to be showing you a book that I really, really love. And this book is called Windblown. And I don't know whether or not, yeah, there we go. We can see Windblown is the name of the book. And it's written actually by Edward Manseau. And it's a book that's been out for quite a while. But what Edward does in this book is that he starts off, and maybe you can put me nice and big there for a second. Yeah, for sure. Just to show the book as well. So in this book, and I'm just going to go off to the side here, there are just different little loose pieces that Edward starts with. And so in the book, there's just random little things, and more little pieces come along in the book. And by the end, all of these pieces, where did they come from? Whose are they? And you can see all the pieces there. And the author turns those pieces into whatever kind of animal he wants. So they're mine, said the chicken. I saw them lying around. And he's taken just those pieces and turned it into a chicken. So he's decomposed all of those pictures, or all those pieces, and turned them into something new. Oh, nope, they're mine, said the bird. So the bird is created. And you can see they've added some black lines just to make it kind of fun there. And I'm not even going to show you the next page, because we're going to take something and take a look at that as well. But the wonderful thing about this book is at the very end, the wind blows all the pieces off to you, and you can actually create a windblown picture of your own by cutting out the pieces and seeing what you can come up with. And I've included the link to the PDF for all those shapes for the teachers as well. So if you put us back onto our slide deck again there, James, we'll see that we're going to give directions to create something, okay? Those clear directions to actually get it there. And so if I take a look at my directions for this, it says code for my windblown animal. Number 1, place the orange shape with the right angle next to the short squiggly line on the left with a quarter of the orange shape below the squiggly line. That's a huge amount of directions. And we never, ever want you to try to do that, especially in kindergarten and grade 1. But we can do that today because we know what is going to end up happening. So I'm taking the orange shape, I'm putting it next to the squiggly line, I'm leaving about a quarter of it down below, and I'm just going to plunk it there. Okay, so that we could have really, really complex directions, but we don't want that. We want really simple ones. So if I go on to our next little area here, I already started a bit of a picture. James, can you take a guess what my animal might be from what you can see there already? And boys and girls, if you want to take a guess, put it in the form. We'd love to hear it. Sister Zubada, if you want to get your kids to figure out what this is, that would be great. All right. Any idea what it might be, James, that you think I'm going to use those windblown pieces for?
I'll say ladybug of some kind.
Ah, there you go, because you see what looks like maybe 2 antennas. All right. Well, I'm going to move my pieces over because we don't want to take too much time with this. So this almost to me looks like a mouth. So I'm going to kind of put it over here for now and let's see what ends up happening. And this is the great thing about these pieces. If you have the pieces of paper, you can move them anywhere. I'm going to put this guy maybe right here for a body. And I liked your idea of a ladybug, but it's, for me, I think it's going to be kind of, oops, let's, oh, maybe I can just move my antenna.
Oh.
Yeah, what do you think?
Oops. Is it a snail?
I'm going to turn it into a snail, yes. But for some reason, there we go. He's not moving too as easily. I've got his antenna in the middle of his eye, but that's okay. I could have turned his eyes around too and had that happen as well. Let's just put this one kind of up that way. There we go. And voila, right? We've decomposed. So we've taken all the parts and we've turned them into something new. All right. So that'll be something that you'll be able to do at home as well. I hope that, yep. And Ishrath said, it's a snail. Good job. Well done. So it's there. All right. So do you already have an idea for what your windblown creature could be? Because these are all little things that you can do with your teacher after we're finished here today. If you do, put your idea into the form and we'll keep watching for that and see, okay? That's great. All right. So pixel art is also something that we can do completely uncoded. And you know that when you look at a computer, every single image that you see there is just made up of thousands and millions of what we call pixels. And they're pixels because they are picture elements. So pixels, they put the pic and the L together and get a pixel. And you can see just from this one coming in and out, it looks like it's just a little figure until you really zoom in on it. And then you can see it's just a whole bunch of tiny little squares. And so we can make all kinds of creations using just tiny little squares too. And you think about, you have Lego in your classroom, then each one of those little square Legos totally could be created into a character of some kind. You can make emojis out of it as well. But we're going to do something a little simple today because we know that we want to start simply and then you can go on from there, okay? So binary coding is what we're going to talk about, and computers can't actually see pictures, right? The images have to be turned into numbers, and every single color has a number, okay? So we're going to take and figure out how we can actually look at that with just 2 colors and 2 binary code, 2 colors, right? 2 codes. So we have something here. There's a picture here. The computer would know what it was immediately. But if you look on the right-hand side, we've got a code. We have a legend telling us if you see a 0, it's going to be what color, James?
Black.
It's going to be black. And if we see a 1, it's going to be white. So basically for today, we could leave the ones almost as white because they're already in a white background. But let's take a couple of these blacks because we say a 0 is a black. Oh, I see one right on the very top row. I'm going to put it there. And I'm wondering if our friends, before we actually construct this, whether our friends at home can take a look and figure out what this is going to be. I'm going to keep putting the black onto the zeros because black is 0.
I still don't know what this is.
You don't know?
No, not yet.
Good. That's cool. That means that you get to be still guessing as well. Huh. Okay, there's the second row done.
Is it an animal of some kind?
It's not. It is not an animal. Oh, and I'm waiting for answers. Come on, Ishraf. What do you think it is? What's going on there, James? What do we got? All right. Now, this whole row is black, right? It's all zeros. So let's put all of those in. Is that helping at all? Oops.
I hope Ishreth gets it before I do because
I do too. I think that would be great. I'm watching. I don't see it there yet. All right. We only have 4 zeros left. What have we got? What's going on? What do you think it's going to be?
and now I'm sitting back so I could zoom it out, if you will.
Right. You have to see it as a bigger thing. And don't forget, I mean, this is only just 5 by 5 pixels. If we had 1,000 boxes, it would be a lot more smooth with what you're actually seeing. Any ideas now?
Is it a house?
It is. Yeah.
Oh, okay.
It's a house. Oh, and Ishraf said a bridge. Good for you. Oh, and I love that, Ishraf.
You know
yes.
what? I like Ishrath. No offense to your project, but I like Ishrath's answer better because what threw me off is that the ones in the middle are if it was blacked in, I would say that maybe that's a house, but that looks more like where I'm from, the Golden Gate Bridge in San Francisco, which is where I was born and raised. So that reminds me of the Golden Gate Bridge.
Oh, that is so cool. And that's perfect. And that's what I love about being able to see it. And you're right. That's maybe look more like a house, right? With that extra one in there. All right. Well, that is so cool. So just by being able to code with 2 colors, right? 2 numbers, 0, 1, 0, 1, 0, 1, which is what a computer does as well. But we're humans, so we can actually do this ourselves too, but just with those 2 colors. So yeah, we know that it's saying white, white, black, white, white. White, black, 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 white, black, 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 white, black, white, black, white, white, black, white, black, white. And that's if we're coding it and we were saying this, that's what we would saying. But that's a ton of words. And we don't want to say that many words all the time. Could you imagine if we were trying to create something that was 100 by 100 squares? Oh, it would, our whole entire day would be just talking. So we can make it easier. And that's what the computer does. It starts to make it easier as well. So if we take it and we notice the patterns in the pixels, we can actually group things together now. Okay. So if we look on this row 1, the very first row, we have 2 whites to start with. So if I look over here, my code could be 2. And as long as I always know I start with white on every row, so that's going to be my direction. That's my algorithm, is I'm going to tell everybody every time I'm always starting with white. So I have 2 whites, 1 black right here in the middle, and 2 whites. So row 1 is so much simpler than saying white, white, black, white, white, and starting from there. Now take a look at row 2. It says 1, 3, 1. No problem. Here's where we have to be tricky. Are there any whites? No. So on row 3, we have to put a 0 there because there's no whites. So there's no whites, but there are 5 blacks. Okay? So coding, being able to just start to put it this way, and for our grade 2s and 3s, you'll start to understand this a lot more as well. And there's even another step that you can do that we'll take a very quick look at. But for our younger students, you can still see now this row is 1, 1, 1, 1, 1, because we kept going white, black, white each time, and it's there. Okay, so just a little bit of extra coding for us to think about as well. Any questions with that, James?
Makes sense to me.
Good. Yeah, that's perfect. All right. So, we have one. I've got a grid of 25 squares, 25 pixels. All right, we know that our colors, black is going to be zeros and whites are going to be ones. So let's try it. What do I put on my very first row?
All black.
All black. Okay, and I'm going to do this hopefully a little bit faster. Copy, paste. Five of them. All right, I like that, right? We said over here, row one has 0, 0, 0, 0, 0. So 5 zeros, that's fine, 5 blacks. Our next row is going to be what?
It looks like one black
Yeah,
and then four whites.
4 whites. Oh, okay, so I can just leave this next row. Let's move that up just a tiny bit. We can leave 1, 2, 3, 4, because over here, you're right. We say 1, 1, 1, 1, and 1 is white. Okay, beautiful. Row 3, please. What are we doing?
We're going to do one black, and then we are going to have one white,
Okay.
and then three blacks.
Oh, and then 3 blacks. Okay. I don't know. Robin. Oh, ho, ho. Yes, Robin. Yes, we do have this slide deck you get to completely share and use. Absolutely. And that's why I know that as we're doing some of these things, if you want to pause as well and do things and come back to us, you certainly can. But it just means that you won't be live with us on the forum as well. So no problem. All right. So I have to ask our friends, right, back in the classrooms. And I know we have some new friends that have joined us. So I hope you have your Bitly open. It was that Bitly / Logix form 2 is where we need, so you can give us some answers. And I'm wondering, can anybody have a guess at all about what this is already? Because we look at row 4, we only have 2 rows left to go. And if you notice, row 5 is all zeros. So row 5 is all black. I'm going to put that in, maybe just to make it a little bit tricky for Ishrath, because Ishrath is like guessing these really, really well. All right, so there's that black. Let's just put, yeah, I'll just, I think I already copied that. Oops, yeah, I don't want it up there. I'll do it down here. And copy, paste. So there's 5 blacks. 5 blacks. Oh, no, you know what? That confuses even me now when I look at that. Although, I would almost guess, I'm going to give a hint. Okay, going to give a hint. What if this was a letter of some kind? What letter do you think it might be?
Are you asking me? Or are you asking everybody else?
I'm asking everybody. Oh, Ishrath says it's a maze, and it totally
Hmm.
could have been. You're absolutely right, Ishrath, but it is not. It's going to be a letter. So take a look at that row 4, and where are the black ones going to be? I hope there's like all kinds of conversation going on right now in those classrooms. What is it? What is it? Put in the 2 blacks. Where do they go? The 2 zeros. I'm watching this. I'm watching the forum. I want to see somebody come up with it. I'm going to put 1 in. Oops. I went down on my other screen. Oops. Come here, you. 1. See if that gives you more of a hint. What letter? And it's only row 4. I'm going to put a black one. Oh, so it's 0, 1, 1, 1. So black, white, 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 black. It has to be a dead giveaway now. The letter G, right? The letter G. Okay. So, or if we, and I'm going to just go to the next slide here because I think I even have that. Yeah. What do you think is being coded? There you go. We've got that already, so we know. But again, oh, there we go. Thank you, Miss Gorman's class. Miss Gorman's class, welcome. Good to see you here. That's wonderful. So you're right. It is the letter G. So we know that that letter G is going to be there, and this is again is like what we did before, James. So instead of going 1 1 1 1 1 0 1 0 1 0, I can look at it. Every row starts with white, and we're thinking about that again. And I know this is a bigger thinking thing for some of our older students. So if I start with white every time, I know that
Mhm.
there's no white. So again, I say 0 and 5. Then I have 0, and then one black. That's right, one black, and then the 4 whites, 0 whites again, 1 black, 1 white, 3 blacks. So I know that for our younger students that this might be a little bit above what they're doing, but definitely conversations for our grade 2 and 3 classes can take a look at this and try and figure it out as well. But it is definitely now going to be your turn. And I know that this is not something that the teachers already have supplies out ready to go. So this is going to be something that, because we're getting close to leaving you very soon as well. So we're going to let you continue with this and be able to go get supplies and do this at your own speed and wherever you want to do it. So think about what letter you're going to choose. Okay, and maybe share that with us as well in the form. Let us know, what letter are you going to choose to try and do to actually code and have somebody read your coding and be able to create that for you in front of you and see whether it works or not. And don't worry, even if there's a mistake in your coding, you're just going to debug it. So you're just going to find out, oh, well, I thought that I told them that it was supposed to be 0, 1, 1, 1, but you really wanted to have 0, 0, 1, 1, 1. And if that happens, then you change your code. And that's what coders do all the time. And then you make it so that it works the way that you want someone else, without you talking to them, are able to actually read your coding and be able to go from there. So I said on here, what materials are you going to use to make your algorithm? Because we don't have to use computers at all, right? We can use all kinds of things that are in your classroom or outside on your sidewalk. So think about the fact that you could use magnetic squares if you have those in your classroom. So create the squares and then plunk down little, I don't know, you might have just little balls that you can put down and have 2 different colors and have the shape of the letter come out. So in the top corner here where I have those magnetic squares, you could just put 5 by 5 squares together and then have 2 different colors of Lego and place them in so that you can see what letter you want somebody to code for you. But remember, you're going to have to give them those instructions. You could say it, that's fine and dandy. You could say 0, 1, and give them a legend. Tell them that 0 means that it's green and 1 means that it's red, and then use green and red Lego. That's absolutely fine. But whatever you use, your instructions have to be very, very clear in order for you to be coding and going with them. Yeah. Is something you wanted to add there, James?
Well, and I'm thinking too, if I know that we're doing things offline primarily with this, and I know some people don't always have graph paper, but you could use graph paper. And if you're like, well, we don't know where to find it, you can use an Excel spreadsheet and print out a grid on an Excel spreadsheet. So there's different ways to make your grids as well too.
Absolutely, completely. And I really, really like when you get the slide deck as well. I've actually also put right here, I was talking about Lego earlier. Well, Lego has actually created a neat page with all the directions and all the different arrows that you can cut out and place down on your floor, on your desk, whatever, and have somebody actually follow through and figure out what your code is as well. You can see here on the floor in the middle here that they have a track or a squares. They'll have to tell, how does this truck make it over to the fire station? Or remember, we talked about fairy tales as well and stories. So think about that, about how those things can be coded. I love this idea of using an egg carton, right? That can be your squares as your egg carton, and just place in any kind of manipulative you can place into them and have somebody else recognize your initial, whichever letter it is that you want to use. You can see here on the floor, they've taken big pieces of paper and just had the paper as those are their directions that they have to go as well. You can also, and I really enjoy this too, if you have a classroom, look down at if you have a classroom, you all have a classroom, but in your classroom, some of you may have squares on your floor. And if you have squares on your floor, you can use those squares on the floor to be able to have somebody follow your coding. Okay, and send your person. So have your partner stand on one of those squares and say, walk forward 2 squares. and they have to walk forward 2 squares. And you can have a point picked in your classroom where you want them to reach. And if your coding is correct and they get there, celebrate. That's amazing. But if you do your code and they didn't get to the spot you thought, debug your code, find out what instruction you didn't give them. And quite often it's a turn, isn't it? That's often what we miss. Yeah. So anyways, and so as you can see, you can use pieces of fabric, just anything at all that you want to have that's consistent, then please use it and do your unplugged coding. Okay. All right. Well, James, I think this is just about it here. We're wrapping up, I'm afraid. So please have fun, everybody. Let us know. Logix Academy is on all social media. So if you tag us in any of the little things that you do, if you do some unplugged coding in your classroom now after we're finished here, please, if you take some pictures and just don't take faces, share with us, share it on your social media and just tag us. That would be amazing. We'd love to see what's actually been happening in the classroom. And just in case you want to as well, just one last little idea, you could have everybody in your class have a different algorithm. They could choose what they wanted to do, put out a big piece of mural paper and have them all do their algorithm, their little part of the code in the spot that they're on the paper, and see what happens at the end and see what artwork you come up with at the very end of it all. And there's that social media thing again for you too. All right. All right. Have a lovely day, everyone. And James, anything you'd like to say to finish here?
This was wonderful. Thank you so much for allowing me to be a part of this.
Oh, absolutely. Thank you for being a great sport and a great finger in the ear person. That was, I appreciated that as well. All right, everybody. It's been grand and thank you so much and have a great day.